Hello everyone, welcome to another technical deep dive. My name is Cody, and in this episode we're going to provide a comprehensive overview of an entirely new DeepHub entity called anchors. We will explore what they are, how they can be managed with the admin UI and the DeepHub REST API, and how they can streamline your RTLS solutions. The infrastructure of real-time locating systems, such as those utilizing ultra-wideband or Bluetooth low energy technologies, typically consists of two key hardware components: tags and receivers. A tag, sometimes called the transponder, is a wireless device attached to an object that tracks the object's location by transmitting signals. These signals are detected and captured by receivers, which are strategically placed throughout the indoor tracking area at fixed locations. These locations serve as reference points for the locating system. Depending on the specific RTLS, receivers may be referred to as satellites, readers, locators, or anchors. In the DeepHub, a receiver is represented by an anchor entity. It's not mandatory to configure these within your DeepHub instance. However, doing so may be a convenient way for you to comprehensively manage your system without having to switch over to the software of the RTLS vendor. In this way, the DeepHub serves as your one-stop shop for all your configuration requirements through its seamless integration with the locating hardware. Let's now look at how you can manage anchors with the admin UI and with the DeepHub REST API. Anchors and zones are intrinsically related to each other, as a zone represents the tracking area covered by anchors. For this reason, we'll begin by creating a zone. Next, we'll create an anchor by first clicking Create Entities, and then Anchor. We'll give it a name, and select the ID of the zone we just created. By clicking the blue Locate button, we can set the position of the anchor. Alternatively, we can define the local coordinates of the anchor in meters relative to its corresponding zone. To visualize the coverage area of the anchor, we'll add some custom properties. One for the distance in meters, and another for the horizontal range in degrees. Please note that these exact custom properties must be used. Finally, we will set the local azimuth angle and the global azimuth angle in degrees. These properties describe the horizontal alignment of the anchor locally in relation to its corresponding zone and globally, respectively. The elevation angle may also be set, which defines the vertical alignment of the anchor in degrees. As properties are adjusted, changes are visualized in real time in the UI. Once I'm done, I'll hit Save. To edit an anchor, first click the gear icon, and then Anchor List. I'll left-click on the anchor in the list and adjust its properties. Once I'm done, I'll hit Update. Managing anchors with the admin UI is streamlined and intuitive, however, the possibilities are even greater with the REST API. With the REST API, we can create, update, delete, and retrieve information related to anchors. To get a summary of all anchors, we can use the Get Anchors Summary endpoint. A 200 OK status code indicates the request was successful. The anchor we previously created within the admin UI is shown in the summary. As we can see, the anchor has local coordinates but does not have geographic coordinates. This is an important point to note. Anchors created through the admin UI only include local coordinates relative to their zone, not geographic coordinates. However, when creating anchors with the REST API, we can add local and geographic coordinates to them. To create anchors, I'll use the Post Anchors endpoint. In the body of the request, I'll provide an ID, a name, a zone ID, a local position with local coordinates, a georeference position with geographic coordinates, a local azimuth angle, a global azimuth angle, and an elevation angle. One thing to note, my system does not yet have a zone with this ID. I'll explain why in a second. A 201 status code indicates the request was successful and that the anchor was created. Now I'll repeat this process 3 more times to create 3 more anchors. Now that these 4 anchors have been created, we'll be able to see them in the admin UI as well. Because these anchors have local and geographic coordinates, they can be used as ground control points to create a corresponding zone. The ability to create zones from anchors greatly simplifies the process of precisely creating your zones. To do this, we will use the post zones endpoint to create a new zone. In the request body, we will set the foreign ID to the same zone ID that was used when creating the anchors. We will also set the transformation type to ground control points and add the IDs of the anchors we just created. Back in the admin UI, we can see this newly created zone that was generated from anchors. To update a specific anchor, we can use the put anchors anchor ID endpoint. Once my changes are done and the request is sent, we can see the updated anchor in the UI. Finally, we can use the delete anchors anchor ID endpoint to delete a specific anchor, or the delete anchors endpoint to delete all anchors respectively. Back in the UI, all my anchors are now gone. The addition of anchors into the DeepHub is yet another way we aim to simplify and streamline your location data management. Spending less time on cumbersome configurations enables you to spend more time deriving actionable insights from your data. We encourage you to explore anchors for yourself and leave any questions or comments down below. Thank you for watching. Please like and share this video if you found it helpful, and subscribe to our channel for more future DeepHub content.